Hi everyone. We know Terahertz is one of the top 10 leading technologies that can change the future world. It can be widely used in biomedical and biochemical science, 6G communication, high-resolution radar, security check, and 3D material imaging areas. Ceyear can offer electronics-based 2-to test solutions from 50 GHz to 1.1 THz. Today, we call the THz Signal Generator and Analyzer systems here. We can create and analyze the 220 GHz to 325 GHz signals. Two horn antennas are used to transmit and receive the signal through a free space coupling. On the left are the 1566 L-V signal generator and 82406D THz exchange module. We set the signal generator's multiplier factor to 18. Thus, we can directly set the module's output frequency to 300 GHz. We set the signal generator's power to 5 dBm to drive the module's RF input. The horn antenna has a 23 dBi gain, and the two antennas are placed face-to-face in the line. On the right are the 4052F Signal Spectrum Analyzer with a THz mix module. The Spectrum Analyzer extension module can down-convert the THz signal into the analyzer's intermediate frequency. The analyzer will further process the RF signal and give the corresponding results. Here, the RF is 425 MHz, and the LO is from 8 GHz to 20 GHz. Once the cables are connected to the analyzer, we press the I/O menu on the top screen, select the external mixer label, and switch it on. We also enable the signal recognition function to automatically remove unwanted harmonic and image signals. This is a 300 GHz signal spectrum with a 105 GHz span. We can say the harmonic suppression is more than 30 dBc. We change the center frequency to 300 GHz, set the span to 20 GHz and RBW to 3 MHz. We keep decreasing the RBW to 500 kHz, to 200 kHz, to 100 kHz. Because and 100 kHz RBW, the FFT is automatically turned on. The signal recognition function is switched off accordingly. We set the span to 1 GHz, and then set the span to 500 MHz. We set the RBW to 1 kHz. Span to 200 MHz and RBW to 500 Hz to 200 Hz. Now we set the reference level to minus 30 dBm and the vertical scale to 15 dB per division. Here we change the reference level to minus 10 dBm. Keep decreasing the RBW to 50 Hz. The peak remains at about 15 dBm. We set the signal generator to 320 GHz. The antennas are very close now and about 5 cm apart. The analyzer's center frequency has been set to 320 GHz and RBW to 50 Hz and span to 50 MHz. The peak is at 320 GHz and the power is about minus 10.6 dBm. What will happen if we insert something between the antennas? We insert a 180-page Terahertz academic journal between the antennas. The peak changes to be minus 23.5 dBm. The attenuation is about 13 dB. We insert an anti-static packing bag and get a minus 36 dBm peak. The attenuation is about 26 dB. This book has 1,300 pages and is about 5 centimeters thick. The peak changes to be minus 93.8 dBm. The attenuation is about 83 dB. I put my palm between the antennas. The peak power turns to be minus 108.9 dBm. The attenuation is about 98 dB. We can see different materials have different absorption properties for terahertz signal. Actually, scientists and engineers have special testing ways to get more information and get insight to the nature behind the appearance.